Here is the final section or the final video of section 4.1, and we just have two relatively quick word problems to do. Now, number 8, there's quite a bit of reading, but basically what happens is we are interested in this right triangle that is given. And so I'm just going to duplicate that, where there is theta given, here is a right angle, and we know that since the sun is represented right here and the earth is represented right here, this distance right here is approximately 150 million kilometers. And we want to know what is this distance right here. We're also told that theta is equal to 0.314 divided by 3600 degrees. And it's due to the fact that there's 0.314 arc seconds, and this is a conversion from arc seconds into degrees. And so if we look at the angle, we know the opposite leg, we want to know the hypotenuse, that would represent the sine. So we need to find the sine of 0.314 over 3600 degrees has to equal 150 million over x. Or in other words, x is going to represent 150 million divided by the sine of 0.314 over 3600 degrees. And we are told to determine the distance. Understand that the approximate distance being 150 million kilometers, we can certainly round to the nearest million. And, give or take, at that point, give or take a million isn't really going to mean a whole lot. So we put in 150 million and divide by the sine of 0.314 divided by 3600, and we get, it goes into exponential form, but it's basically 9,853,414,311 with 4 zeros. And so even though I went into the nearest, what appears to be 10,000, that's fine too. So it appears that we have, I've missed my fractions up, 98,534,143,110,000 miles. And of course at that distance, give or take a million is certainly sufficient. And finally, example number 9 deals with some bearings, and we want to try and get some relatively accurate things, otherwise our final answer may not make a whole lot of sense. But basically we have a sailboat that leaves port on a bearing of south 72 degrees west. Well, the south tells us we're going to be going in this general direction, but from this general direction we're going to go 72 degrees in the westerly direction. So this angle right here is 72 degrees. Now we're going to be sailing for 2 hours at 12 knots. Well, after 12 hours we will have gone 24 knots. That's being used in this case as a distance. Then the boat turns 90 degrees towards the south. So in other words, we're going to have a 90-degree angle right here. And it sails for 3 hours at 9 knots. So this would make 27 knots at this location. What is the bearing to the ship from the port? So in other words, we are asking, what would this bearing be right here? Well, to me, this is pretty well screamed, and it says round your answer to the nearest tenth of a degree. Basically, what we're asking is, what is this angle right here? Because if we can find this angle, we know the entire angle right here is 72 degrees. So once we find this angle, we just have to subtract it from 72, and that will give us this, and then we'll be able to answer the question that is being asked. So with respect to, let's just call it theta. This angle here, we know the adjacent leg and the opposite leg. That would be the tangent. So the tangent of theta better equal 27 over 24. Or in other words, theta will equal the arctangent of 27/24. And so here we have to just use our calculator, because 27/24 is not a very common fraction, and it certainly doesn't show up anywhere in the table that I gave you. And we are told that theta would be then 48.4 degrees. So that's this angle right here. So the question is now, what would this angle be? Well, total is 72, so we just have to take 72 minus 48.4, and we get 23.6 degrees. Now that's not the bearing. The bearing is still going to generally be in the south direction, so it's going to be south 23.6 degrees, leaning towards the west. Now, if by chance this line would have come over here, it would have been south something east. That's the only difference. But for this particular problem, the answer is south 23.6 degrees west.